Yo, look up at the night sky. Looks pretty peaceful, right? Just a bunch of stars chilling, doing their thing. But what if I told you that the entire universe is on a cosmic timer, and eventually, absolutely everything you see is going to get completely wiped out? I'm not talking about the Earth getting cooked by the sun. I'm not talking about the Milky Way crashing into Andromeda. I'm talking about the end of space and time itself. The universe's ultimate expiration date. Is reality going to freeze to death? Is it going to rip apart like a cheap t-shirt? Or is the universe's physics engine going to glitch out and delete us with zero warning? The universe is low-key unhinged, and the ways it could end are actually terrifying. No cap. Stick around, because by the end of this video, your entire perspective on reality is going to be permanently altered.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
What is up, guys? Welcome back to MindSpark, the only place where we take the craziest, most mind-bending facts of reality and break them down until our brains literally cannot compute anymore. If you're new here, we dive deep into the science of the impossible. Today, we are looking at the ultimate finale, the end of the universe. For real, physicists have been crunching the numbers, looking at how fast the universe is expanding, and they've come up with a few main theories on how this whole simulation shuts down. We're talking about theories so wild, they make sci-fi movies look like a joke. We are going to break down the actual astrophysics behind how everything goes dark. Grab a snack, lock in, because we're about to let the universe cook right before it turns into nothingness. Let's get into it. Theory number 1. This is the most widely accepted theory among astrophysicists right now. It's called the Big Freeze or heat death. And honestly, it's giving Major L energy. Here's the deal. You guys know the universe is expanding, right? Ever since the Big Bang, everything has been spreading out. But it's not just expanding, it's accelerating. Dark energy is out here acting like a chaotic antagonist, pushing galaxies further and further apart. Now imagine this keeps happening. Galaxies get so far apart that they can't even see each other's light anymore. The sky goes completely dark, but it gets worse. Over trillions of years, the stars are going to run out of fuel. They'll burn through their hydrogen, explode into supernovas, or just fizzle out into white dwarfs. Eventually, the universe runs out of the raw materials to make new stars. The lights start turning off one by one. The universe is officially broke. No new energy, no new stars, just dead planets, dead stars, and black holes. But wait, let him cook. Black holes are still around, right? They have massive aura, consuming everything. Well, even black holes aren't safe from the Big Freeze. Thanks to Stephen Hawking, we know about something called Hawking radiation. Over unimaginable time scales, we're talking a Google of years, which is a 1 with 100 zeros behind it. Black holes will slowly evaporate. They just leak radiation until they shrink down and pop out of existence. When the last black hole evaporates, the universe reaches maximum entropy. No heat, no movement, no light. Just a cold, dead, infinite void hovering at absolute zero. The universe doesn't go out with a bang. It goes out with a whimpering. Okay, so the Big Freeze is depressing. But what if gravity pulls a reverse Uno card? Enter the Big Crunch. So dark energy is pushing things apart, right? But gravity, which has absolute W-riz when it comes to pulling mass together, might eventually say, nah, I'm the main character. If there is enough matter and dark matter in the universe, gravity's pull could eventually overpower the expansion of space. Picture this. You're looking up at the sky billions of years from now. Instead of galaxies drifting away, you see them getting bigger, brighter. They are coming right at us. The expansion of the universe stops, pauses for a second, and then starts contracting. It starts slow, but as things get closer together, gravity gets stronger. The contraction speeds up. Galaxies collide, throwing stars out of their orbits. The temperature of the universe starts skyrocketing. Space itself is getting squished. Eventually, the cosmic microwave background radiation, the leftover heat from the Big Bang, gets compressed so much that the actual vacuum of space becomes hotter than the surface of a star. You wouldn't even need to be near a star to get cooked. The empty space around you would literally vaporize you. All the matter in the universe, every planet, every star, every black hole gets shoved into one infinitely dense, infinitely hot singularity. The ultimate cosmic mosh pit. Everything is crushed back into the exact same state it was in right before the Big Bang. A massive, universe-sized reboot. Speaking of reboots, some scientists think this leads to the Big Bounce, where the crunch triggers another Big Bang, meaning our universe might just be stuck in an infinite loop of dying and being reborn. Honestly, that's valid. All right, shake that off. Because this next theory is where things get genuinely unhinged, the Big Rip. If the Big Freeze is slow and boring and the Big Crunch is a giant trash compactor, the Big Rip is the universe literally tearing itself to shreds. Remember dark energy? The mysterious stuff expanding the universe. Well, we don't really know how it works. What if it doesn't just stay at a constant strength? What if its power increases over time? This hypothetical upgraded dark energy is called phantom energy, and it is an absolute menace. If phantom energy takes over, the expansion of the universe doesn't just push galaxies apart. It starts accelerating so fast that gravity can't hold anything together. About 60 million years before the end, the gravity holding our Milky Way together fails. The galaxy rips apart. Stars are scattered into the void. 3 months before the end, the solar system gets cooked. The sun's gravity can no longer hold the planets. Earth is violently flung out into deep space. 30 minutes before the end, the Earth itself explodes. The gravitational bonds holding the planet together snap. The crust, the mantle, the core all ripped apart. In the final fraction of a second, the electromagnetic forces holding your actual atoms together fail. Molecules shred. Atoms rip apart into protons and electrons. And then, space itself stretches infinitely fast. Reality is shredded at the subatomic level. There is no space, no time, no distance. Just torn up fundamental particles floating in absolutely nothing. It's a flawless victory for dark energy. We are officially cooked. Okay, so those first 3 theories, they take billions or trillions of years. You don't have to worry about them today. But this last one, vacuum decay, this could literally happen right now while you're watching this video, and we wouldn't even see it coming. To understand this, we need to talk about the Higgs field. This is the energy field that permeates the entire universe and gives mass to particles. Think of it like the fundamental coding of reality. Right now, scientists think the Higgs field is in a metastable state. That means it looks stable, resting in a little valley of energy, but it's not at its absolute lowest possible energy state. It's in a false vacuum. Imagine a ball resting on a small ledge halfway down a mountain. It's stable for now, but if something pushes it, or if it quantum tunnels right through the rock, it's going to roll all the way to the absolute bottom, the true vacuum. If the Higgs field anywhere in the universe drops into the true vacuum, it's game over. It would create a bubble of this new, true vacuum reality, and this bubble would expand outward in all directions at the exact speed of light. Inside this bubble, the laws of physics are completely different. Chemistry wouldn't work. Atoms wouldn't be able to hold together. Everything inside the bubble is instantly deleted and replaced by a completely unrecognizable, chaotic physics engine. Because the bubble expands at the speed of light, you couldn't see it coming. Light from the bubble reaches you at the exact same time the bubble itself does. 1 second you're watching MindSpark, and the next literal Planck second, you, the Earth, the solar system, and our entire sector of the galaxy are just completely rewritten out of existence. It's the ultimate server wipe. But don't panic. The math says that even if vacuum decay does happen, the universe is so massively huge that the bubble might never actually reach us before the big freeze takes us out anyway. So yay. Man, the universe is terrifying. We started out just looking at stars, and we ended up talking about reality-deleting bubbles and space ripping our atoms apart. Let's do a quick recap. The big freeze. We slowly run out of gas and freeze to death in the dark. Zero aura. The big crunch. Gravity pulls us back together into the ultimate superheated mosh pit. The big rip. Phantom dark energy shreds the fabric of space down to the atomic level. Vacuum decay. A physics glitch deletes the universe at the speed of light with zero warning. I need to know right now which of these theories blew your mind the most. Which one has you staring at your ceiling tonight? Drop a comment down below. Personally, vacuum decay lives rent-free in my head now. It's completely unhinged. If this video made you question your entire existence, or if you just learned something wild today, do me a huge favor. Smash that like button, hit subscribe, and ring the bell so you don't miss our next deep dive into the cosmos. You already know we're bringing the most insane science content right here. This is MindSpark. Stay curious, stay questioning, and I'll catch you guys in the next one. Peace.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,